Hello and welcome to this Ranger 4 webcast. Today's webcast will look at building security into your DevOps toolchain. Today's webcast will be brought to you by Florine Kawada at IBM. For now, I'll pass you over to Florine.
Hi, thank you very much. Hi everyone, thank you for being here. My name is Florine. I work for IBM as a application security specialist. The last period, I've been looking at how people can actually be a bit more efficient with security, and partnering with Ranger 4, we thought that it would be useful to have a quick discussion on building security into the DevOps toolchain. So today I'll take you through a couple of slides and explain a bit how I see security in the DevOps and some of the offerings IBM has in this area that could help you. The first thing I want to mention about DevOps is I see DevOps a bit like Formula One. It's all about communicating, collaborating, integrating different systems, and automating everything. And if you think about the Formula One pit crew, they actually excel at all these things. They have to be very fast, very efficient. They must communicate. Everyone must know what they have to do, where they are. And they work at such a level that everything seems to be automated, like everything works perfectly. And for them, this is very important because any disruption into this process could cost them seconds off the lap. They could lose the race, they could lose the title, or even worse things can happen. But when you look at a Formula One car, people ask, but what has security to do with Formula One and DevOps? Obviously, Formula One has to be very fast. Everything has to happen very fast. But if you think about it, in Formula One, the brakes are probably one of the most important security features. And the reason for this is because it actually allows them to go faster. It allows the drivers to go faster. It allows them to take sharp turns. It allows them to have a confidence in their car and make sure that at every single point, whatever decision they make is going to get them to the end of the track as fast as they can. What's the cost if a car goes off the track, if the brakes are not working? Well, as I said, it's going to be a few seconds off the lap. They're going to lose a few positions in the race, and then they probably could lose the title, and sometimes accidents can happen, which is the worst thing. But the essential point here is the learning lesson that we should take is security should be a part of the foundation. If you think about the brakes on a Formula One car, they're an essential component of it. It's probably one of the most expensive components on the cars. And they have to be built in from day one, even from the sketch moment. As soon as they think about making a car, they have to think about how are we going to fit the brakes in? How are we going to make this work? And it's the same thing about security and software development. It has to be introduced from day one. It has to be a part of the foundation. It does work as an add-on. You shouldn't be doing it at the end. It's something you should be thinking from the get-go. But why is security important? Well, if we look a bit at the application security landscape, you'll realize that as time goes by, more and more vulnerabilities are being disclosed about web applications and web application-related technologies. And this makes it very difficult for companies to stay ahead of the security threat. And to further add to that, some of the very old security vulnerabilities, things like cross-site scripting, SQL injection, they're still out there. These things have been public knowledge for probably more than 15 years now, and not a lot is happening in this field. People still don't know how to fix them. People still don't know how to address them. And it's actually a very simple challenge to get rid of this low-hanging fruits, let's call them. There's also another wave of security issues coming from the mobile devices. More and more mobile applications are released every day. Some of them have good security measures in there, but most of them don't. It's a new technology. People don't fully understand it. And sometimes these mobile applications could be entry points into your databases, into your backend servers and services. And it's very important to understand that they can be very easily fixed and very simple to address. And to make things even worse for the mobile Mobile malware is becoming a trend. More and more malware is being released every day. More and more unknown signatures are being seen. And what they're doing, they're targeting those badly coded apps or vulnerable apps to try to exploit whatever they can in order to obtain financial gains. Looking at this sampling from 2013, you can actually see how SQL injection is still one of the big things that show up on the incident list. As you can see here, a lot of them seem to be SQL injection, which, as I mentioned before, it's a very old type of attack and it's very simple to address. We have cross-site scripting as well, which is just as simple to address as SQL injection. And we also have a couple of undisclosed, which could be, in fact, due to SQL injection and cross-site scripting being exploited and data being leaked from the companies. But just before I go into best practices, I think I have just a few advices that people should take into consideration when they think about application security, and especially in DevOps. I think you always have to start simple and be as efficient as you can. What I see people trying to do is they start deploying their application, they've done a lot of work to them, and then they want to apply security. It is a good practice, and you should be doing that, but actually, what's going to be even more effective for you is actually to start with security from the get-go. And the reason for this is if you build on top of something that's already secure, it's going to be cheaper for you, and in the long term, you're actually going to end up finding less and less vulnerabilities because you train your developers and you train your staff to proactively address those. And again, I have to stress that application security is not an add-on. It's not something that you take at the end of your development cycle and throw it in. It's something that you have to continually put in, and you have to continually check for it. You have to make sure that whatever you deliver doesn't have any vulnerabilities, and whatever you deliver should not have any of those basic vulnerabilities like cross-site scripting and SQL injection and precise request forgery. One thing that I hear from people when we talk about application security and security development lifecycle is that security is going to slow them down. And the main reason for this happening is because people actually do it at the very end. As I said before, they develop their application, they develop their product, and although at the end they think, oh, I should apply some security. But because they've actually introduced a large number of things up to that point, they never check their foundation. Now they're going to have a large number of things to deal with. While if they would have been doing this from the beginning, the number would have been much lower, the foundation would have been secure, and they wouldn't have to worry about it in the final stages. One example for being turn simple and being efficient is dynamic application security testing. For web applications, I see a lot of people trying to do complex things, and I see a lot of people trying to do source code analysis. Well, source code analysis is a very good and effective way of finding vulnerability findings. Actually, dynamic scanning is also as effective, and it's much easier to use. It's much easier to onboard and gives you very, very good results in a very short period of time. So don't think what's the latest trend or what's the coolest thing people do. Think about what's the simplest thing and most efficient thing that people do while trying to do an SDLC. A quick look at how this should be used. It's simply just use whatever you have, use the existing workflow. Don't try to create something new for security. See where you could put it into your existing lifecycle. For example, we see people using APIs and command line interfaces to interact with continuous integration tool like Jenkins or Urban Code. And that can actually be very effective for you because you can put security as another step of your build process if that's what you want to do. We've seen people using this during quality assurance. If they have Selenium scripts, they simply run some of that data through application security scanner, in this case dynamic, and record the data and reuse the data. So they don't have to create new things. They don't have to create new processes or create extra work for them. And as the picture on the right shows that if you build from foundation, you're going to make sure that the wall doesn't come down. You would hate it if halfway through your shower, your new patched up wall falls down and all your privacy is gone. So again, whenever you think of an application, think about starting with security. Think where's security going to go in and how I'm going to achieve that and enforce it. One simple example for this is a scenario where you have multiple components being delivered for this great system. And in this case, you have 3 applications, and each one of them is on their stream. They go all the way to the end, and at the end they realize, oh, the final product is vulnerable. The reason for this is just they haven't been doing this from the get-go. They haven't built security from the start. A good example for this is actually having intermediate frequency checks. So whenever you do a bit of work on it, do some testing during the build time, do some testing during the QA, and put everything together and make sure that every single step of this is constructing on something that's already secure, that's already checked. I have a list of application security best practices, and the first and most important thing that I'll say again is walk before you run. Start simple. Pilot a project before you deploy this on a wide scale. Start with the obvious suspects. For web applications, for example, start with, the first 2 of OWASP top 10. For mobile, do the same. Don't try to fix everything at once. Whenever someone does something good, just highlight that story. Show people how you came to have good results. People respond well if they're being recognized. Try to centralize expertise. Develop some application security experts. What I see from IBM's experience is that developers that tend to ask questions around, is this app going to be secured, are the best candidates for this. They will probably be more than happy to take on a new role. And also centralized policy decisions. Make sure that you have a central group of people that always think about security, and they will help everyone else decide where to go with your application scanning, what to do next, and what are the things to look for. Throughout the education, we've seen before that because people think security is going to be slowing down their process, there is a pushback. But if you educate people on that, if you show them how easy this could be, if you show those success stories, things will get easier and easier to onboard as time goes by. Focus your education on your specific workflow. Don't try to take something that you saw somewhere else. As you said, pilot it in one of your workflows, and then focus the education you give to others specifically to what you're going to do, and focus on the critical issues. Again, start with the obvious suspects. Don't try to fix everything at once. Just start with the more essential things or the vulnerabilities that are easier to exploit. Another key point of DevOps is automation, right? And mature organizations have security scanning automated. But that shouldn't stop you if you're starting now to create your own automated system. Once you know how the process goes manually, once you've done a pilot, start automating things. Integrate things into the build process. Make sure that, whenever you have that nightly build or that new feature being built, make sure you also do a scan, a quick scan. Clarify the remediation responsibilities. Make sure everyone knows what your role is. I'm sure that as part of the DevOps, this should be very well assigned. As soon as something is being flagged by a system, by a scanner, make sure that the right developer is going to pick it up and fix it. Also build a feedback loop. What you want to do is sort of try to build this security community internally. And you want to share things between developers because most of the time they're going to see the same issues. It's useful for them to have a central repository where they could see some of the issues being before, see how people fix them, see what's working, and see what recommend best practices. And again, share success stories. And if you have failures, make sure you help people address those and make sure you make it easier for them. Having some vulnerability issues in your application, it's not the end of the world. Making sure that you know about them and fix them is going to make a big change for you. And finally, as always, just don't give up. Just because some things did not work the first time, it doesn't mean that you cannot improve them. So keep going again, on and on. Use your pilots. Identify what are the key challenges for you and try to address them. As always, if you have any challenges, go and ask people about them. Somebody probably was there before and they can help you with it. What I'm going to quickly cover next is the IBM Application Security Framework. And what you see here is something that IBM is trying to create in terms of creating a way of managing your application security and also testing your application security. And finally, we're also trying to integrate with monitoring systems and protection systems so have an overall view of their application security portfolio. The first part of the portfolio is the Application Security Manager. And what the Application Security Manager does, it helps you understand what applications you have in your organization, what's going on, what type of applications do you have going. Are they vital to your business? Are they non-essential wikis that you have some football club on? It helps you prioritize the vulnerabilities that you find. As I said, you need to start with something small, start with the usual suspect. So the Application Security Manager can help you do that, can help you identify those issues that need to be addressed first. It can help you track the status and the progress of your application security testing, making sure that you're always up to date on what's happening. You know, if you have applications that had no security testing in the last week or so, or even more. And in some cases, it can also help you determine if you are compliant or not. You know, things like PCI compliance or OWASP top 10. Do you have anything outstanding there? The second part of the application security framework is the test framework, or let's call them the test components. The first component is dynamic analysis. Dynamic analysis is a way of testing web applications and HTTP traffic to web services. This is very effective for testing web applications that are already deployed on websites that are deployed on web servers that are already in production. We have ways of utilizing traffic. So, for example, if you have a mobile application that is sending a request to a backend service, you can help testing that one as well.
Okay, great.
And the most efficient thing about it is that you get immediate results. A scan can be set up in literally minutes, and results will come back in probably minutes as well, and it will help you identify those areas that need to be actioned immediately. The next one in the list is static analysis. And static analysis, it's the more complex type of security scanning. And the way IBM's static analysis tool works is by doing data flow analysis. We analyze entry and exit points from your application. Then we try to trace data throughout your application to make sure that data is being validated and data is being sanitized. So for example, if you think of a web application, you have a form sending in some login credentials. What we want to make sure is that in those credentials, there are no SQL injection that is going to allow illegal access or that is going to allow someone to simply log in as admin. Static analysis, it's a more advanced way of doing things and requires a bit more experience. But the advantages of it are that you can scan mobile and web applications very easily and look at the exact line of code that needs to be addressed. The next type of analysis is interactive analysis. And interactive analysis is a way of looking at the inner workings of an application while doing dynamic analysis. The advantages of this type of analysis is that you get inside information from the application. So for example, you get a line of code. If you find an issue, it will point to the exact line of code. It will help you identify more issues with your applications because you know the inner workings of your application. You'll be able to gather more knowledge about it and find out what's the next step to take. The final type of analysis listed here is mobile application analysis or runtime analysis. As mentioned before, mobile application analysis can be done as part of the dynamic analysis or as part of the static analysis, but it can also be done as runtime analysis. The advantage of the runtime analysis is that you can simply upload your APK or your final deliverable from an iOS application. You upload it to an IBM cloud, and we give back a report to you telling you what are the things that need to be addressed, what are the things that you should be looking at next. The right-hand side of this is monitoring and protecting your applications. And I think some of the more important things for you are mobile application protection. It's very important to protect your mobile binaries. As you probably know, Android applications are very easy to reverse engineering, and it's the same case for iOS. By reverse engineering applications, you can always get interesting information. Sometimes people let connection credentials in there. They show vulnerable endpoints that attackers could mess with, and they can also reverse engineering your application and steal intellectual property for which you've invested time and money to develop. What I have here is an app scan adoption example, and this is how we've seen people being successful with application security in the past. As I said, what we try to encourage people to do is start simple and start with DAST first, start dynamic analysis. And the main reason is it's because it's very simple to onboard, it's very easy to get results out of it, and the results that actually come out are very easy to address and fix. The second step that we tell people to do is actually start building a portfolio. Try to understand all the applications that you have on your system. Try to understand what type of applications you have, what's the risk assessed with each one of them. And by correlating that information and the information coming from the scanners, you can actually assess which application should be scanned next. What should I actually be looking at in terms of fixing? The third step we recommend is to actually start integrating this application security with your general security program and bring in something like a SIEM system. So you can actually correlate issues found by your application security scanners with events from the system intrusion event manager. Once people have a good experience of dynamic analysis and developers get used to it, once you know who's responsible for what and everything is working, that's when you tell people to bring in static analysis. Static analysis, although it generates very good results, it's also harder to understand and it's hard to put in practice. That's why, as a general advice, we tell people to start with DAST and get some results and start fixing issues. The next step is actually bringing mobile testing in. If you want to do mobile as part of the static analysis, this is the right place to do it. However, if you want to do mobile as part of a SaaS offering, you could actually start with it at step one. If you're only focusing on mobile, you can start with a mobile analyzer because it's simple to use and gives you very, very good results. The final level in application security is actually making application security a complete part of your security practice in general. And at this point, you should have database monitoring tools, you should have a web application firewall, you should have intrusion prevention systems, and you should put everything together and make sure that you know what's happening in your application security, and you also make application security a big part of your security or cybersecurity practice in general. Thank you very much for listening. That was my presentation. If you have any questions, I'm happy to respond to them.